let's start, everyone, and we'll allow people to join us. So hi, everyone, and thank you so much for joining today. This is a pretty unusual meetup. We have so many people joining from different countries across Europe. This initiative was supposed to be small. We were supposed to do it just with Scala Berlin and Scala Hamburg and Marcus, but it evolved into this amazing collaboration between the meetup groups. So from here, I wanted to really thank from the bottom of my heart Scala Berlin and Scala Hamburg, Scala Amsterdam, London, Porto, Lisbon, Munich, Vienna, Kiev for joining this initiative and collaborating. I also wanted to thank our sponsors, without which this meetup would not be possible. So commercetools, thank you so much. commercetools is a Berlin-based company providing highly scalable cloud commerce platform, which advocates for a full-on Scala backend architecture with event sourcing. And today, Andreas Drobisch is gonna show you a little bit of that about event sourcing at scale. I also wanted to thank Ziverge, who helps companies thrive using the competitive advantages of functional programming, that is sponsoring this meetup as well. Today, Ziverge will be donating 1 free ticket to one of the workshops that we are organizing. Together with Marcus, we're going to raffle it among the participants, and we're going to select someone at the end, and you will be able to choose which workshop you would like to attend. So moving on to the talks, we changed a little bit the agenda. So Andreas Drobisch, a senior Scala engineer at commercetools, is going to begin with his event sourcing at scale talk. And then John Pretty from Propensive is going to talk about probing the unprovable. So let's begin, everyone.
Okay, welcome everybody. My name is Andreas Drobisch. I will today talk about event sourcing at scale. This will be a lightning talk, hence the little symbol. It will be a bit long for lightning, but probably short for a talk. First, some words about commercetools. commercetools is a headless commerce platform. That means that in the end, we provide an API for everybody who wants to have a business. So it could be a small business, but we also provide our service to big business who want to do it no matter what they actually have as a front end. So they could do it from your car, from an app. They can build a classical shop front end, and we basically enable them to choose the features that they want from our platform and build a really good specialized experience for their users. And yeah, by the way, we're also searching for Scala developers still. So looking at the classical approach to a shopping site, so how it usually worked is you have the users, they go to their browsers. In the end, this will end up on some server, on some endpoint. And then depending on the endpoint, something will happen. And when they do some action like, okay, I want to add an item to a cart and so on, this was just issued as an insert to some database table where you have some relations to also other tables and other data. And this will also be reflected later than when you look at your cart again and so on. So in this world, basically the database is the source of truth, and you have like the database model was the leading model here. So it always needs to be consistent. In an event sourcing world, this would work a bit differently. So instead of saying, okay, this is now the new data that I have in my table, you would model the experience, or let's say the application, in terms of events that could have different types. Here in this example, I have a cart, this is now empty, and I have different types of events here. So one is the add line item event, and one is the add payment details event. And if I apply these events to my shopping cart, this will lead to some use state, a so-called aggregate state, or also a view, depending on how you want to call it. And you could continue and say, okay, yeah, I had these 2 events. If I add another one and replay them all together, I will have a new state, and I can flip around and always create a state depending on the events that were happening. So this process is called a projection. So you have some type of events, you have some magic business logic, and this will create a new state. And then you can continue having more events and creating new state. And after some time, you might not want to store actually all the events of all the time. We will come back to that later. So you will store one view or one aggregate state as a snapshot to continue on for the next state changes. So because no Scala presentation is complete without the one-liner here, little one-liner how this would maybe look like in a super simplified way. So you just fold over an event collection and the state and just apply it. Easy enough. So what this will give us is it will give us a language of our domain that it is described in terms of changes. And this is a much more natural way to actually describe what's going on in an environment or in the world. So if I would talk to you, I would also say, hey, I went for breakfast, met my parents and read a funny article. And I would not tell you, I'm not hungry. I had sexual interactions +1, haha. So this is not how you would actually present yourself. You don't present the outcome. So in this event sourcing world, contrast to the classical approach, the source of truth are the events or the sequence of events that occur over time on an aggregate. So, and why is it important that those are immutable? First, we like immutable data for concurrency in Scala and in our Scala applications. But in some domains, the event might already be the transaction. So if you have more of a tracking system that gets an event when you have watched an ad or completed a video or something, then this is something that you will actually use in your billing information, for example. So you don't want to have this changed. So, and this would give you automatically some kind of transaction log or audit log just by applying event sourcing. Another good thing is here, because those are the truths, you can replay that events to recreate an aggregate state, and changing the events here would allow change the state, obviously, and then you're basically back on the update model, and then you don't need this, which can be fine. But not needing updates also allows for different storage choices in the end. So one pattern, one architectural pattern that often comes up together with event sourcing, but it's not like a requirement with event sourcing, is command query responsibility segregation, which is a really nice term and an even nice abbreviation. But it only says basically that, okay, you can split up your logic into two models. And this, the writing model in that case does not always need to be an event. It depends really on what your application is. Maybe it's actually a desktop application that can also utilize command query responsibility segregation. But that's just that you separate it already in your application. And why would you do this? Because you usually have much more reads than writes, but this depends on the domain and use case. So it might make sense that you actually use different models. So if you go back to the beginning we had the database. So the write model and the read model are kind of similar. They could be both SQL statements that you execute, but in an event sourcing world, the write model would maybe just an append, and the read model, depending on the storage that you use, could be again a table or some other source where you actually read from in your storage. And if you already have this separated, this also allows that you actually use different storages that are specialized for the models that you want to have. So for write model, you would choose something that can actually do a good append, which gives a good write throughput. And for the read storage, you can choose whatever fits better for the actual API or interface that is going to read. So, but then if you're going that route, you will introduce this arrow here between the write storage and read storage, which is some kind of connection. And of course, this can break. So you need some kind of synchronization. And what this means in the end, you will need to sacrifice consistency. You will have eventual consistency. So you might write something, but it might take some time until this is synced or materialized in your view, read storage, until you can actually read it. So here you really need to do a conscious decision. Okay, how do I reflect that then later in my application? That I have now eventual consistency, and this might also go up into the API layer. So how does our architecture then look like? So we have an API, and people are doing something that we call actions, and they can actually choose in our case between different APIs, but in the end, we will store those actions as something that we call a commit in the Mongo database. And this is still all synchronous. So we have a synchronous update on the view, and then we have a synchronous response. But we also have basically an asynchronous part here that writes the message to a queue and enables other servers to actually work on them. So we have basically a split between a consistent part and an eventual consistent part in our architecture. So how does this commit look like I just mentioned? It is more or less what I showed you in the beginning. We need to know when something happens. So we have a timestamp here on this commit. We have something that identifies this commit. We need to identify to some aggregate. Maybe this is a product or a card. And then we have events that we want to apply on an aggregate state. And this will give us a new version of this aggregate that we can later query. Here also another little sneak peek on how this will actually end up being. So in our case, we have a really rich domain with a rich model. So here we actually have nearly 780 events that are modeling our system. So is everything now unicorns and rainbows? Of course not. Because of the model of having events that then get replayed and model the aggregate state, only a fraction of the data that you will need to store, because let's say you want to store all the events, will be real data in the sense that, okay, what is the materialized aggregate state? And that means you need to have some retention or also truncation or snapshot strategy. And depending on your storage, but also on how you implement event sourcing, you might need to implement this yourself. And this can be a complex topic, but also just storing the events on top of the views is a cost factor and might also be a performance factor. Some storage might make it easier to implement something like that because they also have this retention concept built in, like Kafka, but you still need to think about that. Okay, how much data do you want to store and what's the strategy? Reasoning about events can actually also be hard. So in the end, they're just data, and you still need to figure out, okay, who's actually using those events? How are they contributing to the behavior of your system? And this is sometimes a bit harder than just following method calls, because, okay, you always need to have the projection in your head. Okay, what was going on? What does it mean now when the new event happens, and so on. And sometimes you might also need to duplicate events for related aggregates so that you still keep your model clean. So it can be a bit of a challenge. Another issue is that modeling uniqueness gets a bit harder, because it means you might want to check the aggregate state or the view first to not store conflicting events in that sense. And that might mean that you can just append. And if you combine this with an API where you can have concurrent requests, so maybe somebody is trying really hard to do some action and does it several times, but then you have network timing issues and so on. This might be conflicting. So here you need to control this concurrency. For example, with locking, here is a little sketch how this could look like. But this is also then something that you don't want to have on the hot path, which you usually don't like. Creating a user is not something that is constantly happening usually. All right. Next thing that can be a bit tricky is event versioning. So maybe you exposed the internals, or let's say the schema of an event already in a way that you cannot really evolve it. Then you might end up with new versions of events. That might mean that you need to support the logic that evaluated events further down. So you really need a deprecation lifecycle for the events if you don't want to end up with lots of code paths to maintain in the end. Okay, something that you also should keep in mind is the collocation of the view and events. Looking back at the CQRS pattern, the first model is, okay, I have actually one storage with different models here. This can be tricky if you want to scale out later, because it's nice for consistency, because you can use the consistency guarantees and mechanisms of your storage, but you cannot infinitely scale this big blob here. And as we said, it doesn't make much sense if you have actually different number of queries on both models. This assumption still holds that you usually have more reads than writes. Then the read can actually suffer from too much writing, depending on seasonality and timing and so on. So some thing that I would like to mention in our case is that we don't have just one customer, which is our customer. We don't have one application with one customer that is our company, but we have a multi-tenant architecture. It means we have multiple customers on a shared infrastructure. So you can have actually different load profiles for them. So it sometimes is then looking at what's happening in your system is apples to oranges. So some have really steady and high load on the system and continuously write and so on. And others are just doing that on peak times, basically on with much less load, because, for example, they're more of a B2B customer and they have their times when something happens. So that means you also want to have a tenant level scaling, which is actually a bit easier if you have event sourcing, because you have a way to source those events to a new database or a bigger one once they kind of run out of their instance or they have a noisy neighbor. Here you see, okay, so tenant 3 has a bigger database and kind of an exclusive one because they're so big. Then the other tenants might share one, tenant 1 and tenant 2, and others might not go to this database, but go to search storage with the eventual consistent data. And this is all kind of organized in its own kind of infrastructure DB that here called MetaDB, which knows, okay, tenant 1 lives there, tenant 3 lives there, and so on. So it is like implementation of a zero-time moving of tenants can be easier if you use event sourcing. What it also allows is that you build features that kind of utilize this model in the first place. So let's say you actually want to notify people about something happening based on the action. So they do something, okay, add a line item to your cart, and we translate that into, let's say, a couple of technical events. And then we can now just also use this model to translate it into calls to their storage, so they can also use it as some kind of background processing and are notified about what's going on. We're also working here or have worked on the cloud event standard, which tries to unify how you sorry, how you communicate in the cloud in the subscription kind of style. I'm sorry. So events at the edge. So events, if you have them as a common language, as I showed you in the beginning, so it's much easier to talk about that. You can also use them at the edge, so in your APIs, as something that is same across different kinds of APIs. In our case, we have two APIs. We have an HTTP API, but also a GraphQL API, which the customers can use to, for example, on a mobile device, only get the data that they really want and not get a big blob of resource that you might have in your HTTP REST style API. And also for the developers, it makes clear, okay, yeah, this is something that happens on this event and on this action and so on. Yeah, by the way, we are also one of the original contributors of Ziverge and also still maintaining that. Yeah, as I said, Lightning. My summary here would be event sourcing can be awesome, but you also need to look at the drawbacks. So it's still not a silver bullet, and you really need to look at the trade-offs that you get with these guarantees. Okay, do I want to split this models on different storages? Do I want to syncing? Do I want to sacrifice consistency, or can I just scale like it is? And for us, it was actually a nice starting point and an indirection over this kind of model to scale our architecture up.